also have one more modulated one, and then we'll bring up some more sophisticated machinery. So this is now with a lower offset, and these are this one. You can see that tone that I'm using to modulate this is offset somewhat. Okay, so now the part that I believe Jenny has been waiting for. So I brought a musical instrument. You can watch the frequency content of this. And there are several different things I want to call your attention to. The first thing is I want to call your attention to the fact that the musical scale is not linear. Let's hope it hasn't gone out of tune. Okay, so this is a fairly low frequency. In fact, what's sort of interesting about this is we're lighting up the fundamental frequency. It's there. It's actually very, very small. Your ear is actually interpolating. You can see there's some peaks there. There's the next one. So you can see how they're sort of interlaced in a sense. And they get more spread out. They get more spread out. The separation here. Okay, we don't need to see this. This is not helpful. All right. So now, we now play a scale.
Yeah.
You got it? All right. So what we're seeing there, we're seeing all these Fourier coefficients. Let me play them both at the same time and they will modulate. Or I'll break the rotor. A.
Oh, sped up.
Okay.
It caught up with us.
It caught up. Excellent. So what that's doing is I'm convolving that in frequency. I'm convolving those two tones. Now, these two tones were chosen specifically for a purpose, that purpose being that they're offset by, their frequencies are offset by a small integer ratio. In fact, it's a ratio of 3/2. And slightly out of tune there. And finally. Now, one of the things that's sort of interesting about this instrument is that I can play the same note several different ways. So for instance, play this note. So this note here, I can access this note by playing in a different position on a different string. They're fairly close, but not exactly the same. The spectral content, especially the higher frequencies, which determine the timbre of the note, are different. And that's why, in particular, this note here, you can see that the two notes there are slightly different on the screen, that in fact one has a lot more harmonic content. You can see a different harmonic content if instead I pluck that note. Versus in particular, there's a lot more harmonic content. Why is that? These are periodic functions. In particular, when I pluck a note, it's very much like a decaying sine wave. But when I bow a note, it's more like a sawtooth wave, which has a lot more spectral content, a lot higher coefficients as you go out in frequency. So you can access these different notes. You can play around with this sort of thing. Now, what's also surprising about this is that this is the sort of thing that musicians play off of to access different parts of the instrument and different notes of the instrument. And in particular, here's a piece of music that, written by Bach, has many good cello, no, not just pieces of music, but in particular cello pieces of music are. Now watch the fingering. In particular, there are portions where the fingers shift from their position. This is sort of a home position here. That's sort of a home position. But what I end up doing is picking up that same note with a different finger. The reason being is that way I can access notes that are higher up and give me a little more control over the scale. So this note and this note, and in particular notice the difference. That particular shift happens everywhere in the song. Wants to get on the network. Not a lot. In any event, did you see the shifting in position? So that shifting in position permitted me to get access to different notes a little easier. And in part, what a fair bit of cello and violin and other stringed instrument technique is knowing when and where to change position to select those different notes. So this is the sort of thing that goes into the empirical use of this sort of structure. And the neat thing about all of this analysis is that musicality of that sort of auditory aspects of things is something you can see from a frequency standpoint. Now this is a lead-in to the second project, because the second project has another cellist, not me, but someone on YouTube, who's recorded another Bach piece. And one of the important things about that Bach piece, like the one I just played, is that the key signature changes. In particular, I was playing on this scale, but at various portions I was not using this note. In fact, this note was dropped by a half step, which a half step is a 12th root of 2 in terms of frequency. That drop in half step changed the key. In particular, that particular key change happened at the song. Let me actually now call it out. But then when it goes, this is now a different key. Now we're back in the original key. Different key, but back in the original key. Now one of the things that musicians may take issue with is the fact that I'm noting these very short key changes that are not necessarily musically relevant from a phrasing standpoint. However, from a mathematical standpoint, when I switch from using this note to this note, that switch is something that is, in fact, I'm switching to another key briefly and then going back. And this is actually a characteristic feature of Bach's music. And in particular, he's very careful about making these key transitions not entirely transparent. Where I was calling out those key transitions, you could be plus or minus a few notes on either side and say that the key has changed as well. but I was trying to pick the sort of semantically relevant ones as well. So anyway, with that, that's the end of the lecture, and I hope you appreciate where this project is going with acoustic. So thank you. Hit the stop button on that.